Compressed sensing is, I guess, is a new technique that enables you to collect less data, but use the fact that medical images, much like natural images, are compressible. For example, if you take an image using a digital camera, you can compress it up to maybe 40-fold. But with compressing, the idea is that if the images are compressible, then why we need to acquire all the data in the first place and then throw most of it away? And the advantage in MRI is that we can basically sense much less information, that's reducing the scan time, but still be able to reconstruct images based on the fact that they're compressible. The practical consideration is first is how to measure the data. So you need to have randomness or incoherence in that data. The signal has to be sparse, or in a sparse representations you need to think how to model the signal. But there's a lot of other practical issues. For example, reconstruction time. You have to be really, really quick in order to produce diagnostic useful information. But in terms of the MRI system, different sampling can produce different artifacts and things that are not modeled in the usual model that they use for MRI. For example, there can be effects of field inhomogeneity that you have to model in those cases because it's going to get more sensitive. So if you decide to go for faster imaging using, for example, random sampling, you have to make sure that that doesn't hurt your imaging scheme. The fact that parallel imaging uses multiple receiver coils to accelerate, but the fact that you use multiple receiver coils and the fact that the images are compressible are a different type of information. And so you can use both either to go for faster imaging or better quality images. Well, when you can go fast, then things like motion can be avoided. You can go for high resolution, so better depiction of different anatomy. You can resolve dynamics, so there's different type of tumors that the enhancement or the temporal behavior is very important. So this week you can use with compressed sensing just to get better spatial and temporal resolution. Just get more information for the same amount of measurements. It's going to impact application where you cannot really do it right now. So dynamics, 3 dimensions, more parameters, a lot of implication on diffusion imaging, maybe for time resolved phase contrast, so imaging flow in the heart. Application where just the time to collect the data is just impossible.